So looking at example 5, we're supposed to find the component form of a vector, all right, that represents a plane ascending. So our plane is going up in the air here. It's ascending at a speed of 400 miles per hour at an angle of 155 degrees. All right, let's go ahead and do what the directions say. Let's draw it first. So I'm going to go ahead and make a little grid here. And we are 400 miles per hour, so I'm going to have my length of the vector, the magnitude of the vector, be 400 miles per hour. And I've got an angle of 155. So just like we did on the unit circle, we're going to start at the positive x-axis. 155 degrees would be 25 degrees short of 180. So I would be out in this direction right about here. And I'm going to go ahead and make it whatever length I want, but I'm going to go ahead and say, okay, this length is 400 miles per hour. And this is kind of interesting here for you, I'm sure, because you've never had a length be miles per hour. You know, length is normally inches or feet, or what in the world is this 400 miles per hour is my length? Well, remember, in vectors, the length is the force. It's the magnitude. Our magnitude here is 400 miles per hour. That's the force that's being exerted, okay? And our angle is 155 degrees, so I'm going to put that in my picture as well. So there's what we got going on. We've got a 155 degree angle to our vector, and it's 400 miles per hour. That is a fully defined vector because it has both magnitude and direction. So now we're supposed to find the component form for this vector. Here's one way to do it. You could make a reference triangle and go ahead and figure out that, okay, that's got to be 25 degrees because it's 25 degrees short of 180. And you could use 25 degrees here, use the hypotenuse as 400, and you could do some trig and easily find the y-coordinate and easily find the x-coordinate. Well, trig would be pretty easy to do, but we can fast forward this process a little bit by using the formula up here, okay? It's the exact same trig we would do if we made a reference triangle. It's just in a formula form. Okay, so we're going to find the vector in component form, we're going to take the magnitude and we're going to multiply that by cosine of theta. That'll give us the x-coordinate. And if you look in this picture, that should make sense because using our reference angle here, well, cosine is what I would use to find the x-coordinate. Because you would do cosine of 25 degrees equals x over 400. And then to solve for x, we'd multiply by 400 on each side of the equation. Well, that's all this is. So this is just a shortcut. It's a formula that's basically a shortcut to getting you to component form of a vector a little faster. So I'm just going to follow the formula. 400 is my magnitude, and I'm going to multiply it by cosine of the angle. And I'm going to go ahead and use the 155 degrees, not the 25 degrees, because I need it to end up in quadrant 2, so I need to use the 155. If I use 25, I'd be over here in quadrant 1. Okay, so that will give me my x-coordinate of the vector, and I'm going to go ahead and do the same for the y-coordinate. My magnitude is still 400, but to get the y-coordinate, I'm going to use sine of 155. And again, that fits our picture because if we were solving for this side over here, we would use sine because it's opposite over hypotenuse. We would use sine to solve for that. All right, and then it's just a matter of hitting buttons on your calculator, making sure you're in degree mode, and getting your x and y coordinate. So I'm just going to simply do 400, and I'm going to multiply that by cosine of theta, which is 155. So I'm doing cosine of 155, multiplying it by 400. And I have negative 362.523 if you want to carry 3 decimals. So negative 362.523. And then my y-coordinate, I'm just going to go ahead and do 400 times sine of 155. put that in here. And multiply by 400 here. And I get 169.047. And you can see that fits the picture. I'm definitely I'm way more with the x value than I am the y value. I'm more to the left than I am up. So that fits our picture pretty well. And that's how you can find component form. Now where we're going to go with this soon is we're going to give you the coordinates. You'll have to derive coordinates for the plane, and then we'll give you something like the wind is blowing negative 10 degrees, so the wind will be down here and it's blowing at 60 miles per hour. You'll have to get coordinates for the wind and then see how the wind affects the plane by adding the two vectors together. But we'll get to that when we get to applications. That's coming on Monday. So we'll hold that off for Monday. And we only got one more example to do.